Now I have the bulb with the arrow drawn right side up in front of the mirror, projecting light onto a screen further in the distance. We're now going to come over here and move the light bulb a little closer. And, oh, there we can see a little too much light. We can see the arrow upside down back there. Now all I have to do is measure the distances. The DO is measured from the bulb, from the mirror to the bulb, and I get about 36 centimeters from the front of the bulb where the arrow is. And the distance from the image to the mirror was about 175 centimeters. I'm using a scale of 1 centimeter on the paper equals 10 centimeters on my optical bench. I've got the object in there with the distance of 36 centimeters. Light ray number 1 comes in parallel to the principal axis and goes out through the focus. Light ray number 2 goes through the focus, but it looks like it's not going to quite make that mirror. That's okay, just make the mirror longer. Now it'll go out parallel to the principal axis. Now you might be wondering how come I can make this light ray bend like this, reflect, simply because it's on a flat mirror. Well, it's really curved. I'm just ignoring this curve because all the formulas are based on similar triangles, and the mirrors are supposed to be very thin. So we ignore this little distance in here and just work with the straight line to make it simple to draw the diagram. These light rays are going to converge here, spread out here. If my eyes were here, I'm going to think they came from right here, and that's where I'll see the image. And this agrees with the experiment. The right side up arrow was projected larger and upside down onto the wall. It was a real image because there really is light there. I can see it on the screen. Now we'll use our optics formula to solve for the distance to the image, and we'll see how close we got. That's 180 centimeters theoretical. Okay, I get about 175 centimeters for the experimental. So that's a pretty close fit. And if you take a look at the diagram, it agrees. If you draw this to scale, it will work. It'll verify the math. I measure the height of the object at 3 centimeters. Obviously, the image is much higher. I get 15 centimeters for the theoretical. I measure the height of the image, and I get about 13 centimeters. So my experimental result of the heights is pretty close to the theoretical height. Again, those heights will work out if you draw the diagram to scale. Now, technically, there should be a negative sign in that height formula because the height of the object is up and the height of the image is down.